And you can see here an example. And this, I think this is example B from where we left off on Monday. So you can call this example B. Just put it up there above. And the goal is to find the roots of this polynomial. Looking at this polynomial, we know that the degree here, I'll use green, the degree here is 4. Right? So this is the degree is 4. And because the degree is 4, we know that there are going to be 4 roots, which is why I have an answer key down here at the bottom. And this has 4 roots prepared, right? I have my answer key, and I'm prepared to find 4 roots and to turn in those 4 roots. And there are 4 roots because the degree was 4. And so I was telling the class that I'm okay if we use our graphing calculators or Desmos to find the roots that are real and rational. When I say rational, I mean like a solid number or like a clean fraction. Like for instance, if you were to graph this guy on Desmos, it would look something like this. It would go up forever like that. And on Desmos, if you click, 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 you'll see that we have 4 x-intercepts. But the thing is, not all of them are rational. For instance, 2 is good. And negative 0.5 or negative 1/2, those are good. So in my answer key, I'm going to throw 2, and I'm going to throw in a negative 1/2. I am not going to throw in the 0.775, or it said something like that on Desmos. I forget the actual number, but it was a weird decimal. But I'm not going to use it because I have a suspicion that this is a number that was rounded. I think this number was rounded, and I don't want to give the teacher any answers that have been rounded. I want like the exact roots themselves. So for that reason, I don't know what this is, and I don't know what this is. But I do know that I have 2 and I have negative 1/2. And there are 2 missing answers. And yes, I know that the 2 missing answers are here and here, but I don't want to give the teacher this decimal. I feel like I can do better than that. I can give them a better answer. And so let's find those other missing roots. So let me just erase here this diagram. And here's what we do. Here's what we did in class to find the missing roots. And so what we're going to do, folks, is we're going to go synthetic division. Let me get a marker here. Let's go with purple. And we're going to go synthetic division. Let me draw the large L there. And then let me put the numbers. So we have 10, negative 15. We have negative 16, 9, and 6. And then what we're going to have to do is we're going to have to divide by both of these numbers, 2 and negative 1/2. The order does not matter. Let's suppose that we use the number 2 first. So let's put a 2 out there. And then recall how this process works. You always just drop the first number. And then it's multiplication, addition, multiplication, addition, multiply, add, all the way to the end. So we go 10 times 2. Okay, so that's 20. And now you add those numbers, right? You add the negative 15 and 20 to get 5. And then you go back to multiplication. You go 5 times 2. Okay, go back to addition, back to multiplication, and then back to addition, multiply and add. And it's not a surprise that we get back 0, because you're supposed to get back 0 whenever you divide by a root, right? Whenever you're using a root, you're supposed to get back 0. Now let's try this again, but this time let's throw in a negative 1/2. Okay, so let's run through this again. So you always drop the first number and then go multiply, add, multiply, add, multiply, add. So if I multiply 10 and negative 1/2, it's negative 5. Add them, it's 0. Multiplication and addition, multiplication and addition. And we get back the number 0. Right? The remainder is 0. And so now we've completely thrown in all of the roots. We threw in the 2 roots there and there. And so the only thing left to do is to now build an equation and to solve that equation. And remember that this guy here, that's your remainder. And this guy here, That's your constant. And so now in a different color, remember how this works. You go from right to left, and you give bigger and bigger powers of x as you go from right to left. And so the equation that has now come to life would be this equation right here. 10x squared plus 0x minus 6 equals 0. Let's solve this equation in red, and that'll give us the two missing answers. So let's see, I don't have to write the 0x in the middle. That's sort of irrelevant because it's 0. So really, all I get back is 10x squared, and then it's minus 6 equals 0. Maybe add the 6 to this side. Okay. Then divide by 10, and you guys can reduce. And so now to get x alone, we can square root both sides, right? We can square root. And because you square rooted, you have created a plus or minus pair. And so it seems like we have found the two missing roots. We have the square root of 3/5, and we have negative square root of 3/5. So this is the answer here. You can box this in if you want. Those are the four missing roots, or the four roots. But before you go, stay with me if you would real fast. I want to show you something real fast on Desmos. This will take like 2 seconds. Okay, it'll take a little more than 2 seconds, but stay with me. So let me stop the share and let me reshare Desmos here so you guys can see something. So let me type in the equation originally. Let's get rid of that one. So the original equation said 10x to the power of 4. Watch what happens, guys. Minus 15x to the power of 3 minus 16x to the power of 2 plus 9x plus 6. So this was the original equation. And it had 4x intercepts in this one. But there you see, like there you see the nice one was 2 was nice, negative 1/2 was nice. But that weird decimal, that 0.775 and that negative 0.775, I'll show you what those were. Because those are the square root of what we found. You see that? The square root of 3/5 is what you and I got. And if you turn it into a decimal, you get back this. But it's so much better if you tell the teacher the square root of 3/5, because those are exact answers. This here is a decimal. This is the exact. So if you can ever give them an exact answer, it's much better if you do so. So this was one of the problems that we did from lecture, in case you missed it. So I hope that helped. And if you have any questions, just let me know.